So welcome to Unit 12. In Unit 12, we'll be studying quadratic functions, and we're going to learn what that is in Unit 1, or Lesson 1 of Unit 12. Right, so we're going to be learning about quadratic functions. We already know a different kind of function called a linear function, so let's remind ourselves of how to make a linear function graph. So this is in what form? Everyone should be saying, duh, slope-intercept form, right? Slope-intercept. And that is a linear function in slope-intercept form, so that means the y-intercept is 0, -5, and the slope equals 2. So 0, -5 is the y-intercept, slope is 2. That means over 1 up 2 for a slope of 2. Looks like that. And you take your straight edge and you draw your line. That was my coffee cup being hit with the ruler. All right, so that, what you see on the screen, is what a quadratic function. It is non-linear. It is curved. And a quadratic function is a U-shape. Now, when we plot these at first, you might be tempted to draw a V. There is a function that is a V-shape. It is not this one. This is a U-shape. Now, we're going to plot a few sample points as we usually do for functions. And if I plotted more and more, you would see this, how this is curved. Right? But we're only going to do a few, so I want you to understand that it's always U-shaped. It's curved everywhere. Even these parts up here that seem sort of straightish, they're curved. They're slightly curved. And this U-shape curves out and out forever and ever. All right, so we'll know we have a quadratic function when we see x squared. All right, a quadratic function, right? We did simple ones, simple quadratic functions when we were doing just before Pythagorean theorem. So let's see, which three are quadratic functions? They're the ones that contain x squared. And notice I used function notation, f of x. So these are in the form f of x equals ax squared plus bx plus c. Oh, ax squared plus bx plus c was what we were factoring in the last unit. Is that to help us with this unit? Yes, and we'll get to that later. And so this is the one that's linear, right? Because the exponent of x is 1. The other three will make a U-shape, a quadratic. Okay. Graphs of quadratic are not linear, and they are symmetrical. That means both sides of the U are mirror images of each other. And that U-shape has a name, and you pronounce that parabola. Okay. So describe the shape of each of these functions. Well, the one on the left is a line because it's linear. The one on the right is a parabola because it's quadratic. So the one on the left again is a line because it's linear, x to the first power. One on the right will be a parabola because it's a quadratic function, P-R-A-B-O-L-A, parabola. All right, so we're going to plot the simplest quadratic function there is, f of x equals x squared. So we're going to make a t-table. We're going to plot a bunch of points, right? When x is -3, -3 squared equals +9, -2 squared is 4, -1 squared is +1, 0 squared is 0. And when we say these are symmetrical, you'll notice that this table is also symmetrical, and right, that the y's are mirror images, right? We have a 9 and a 4 and a 1, right? That's going to happen because they're symmetrical. All right, so let's see this. We're going to plot these points. The first point we have is -3, 9. Then we have -2, 4. Then we have -1, 1. 0, 0, 1, 1, 2, 4, and 3, 9. And then we're going to draw a U shape through that, right? And so it's curved everywhere, you know, and if I gave you some points with like 1/2 in them and -1/2, you would see the curve better than maybe here, but it's curved. Okay, and try to hit those points. And this curves out forever. It never curves back in, but it goes on forever in both directions. So we arrows on the end. This really comes down and just gets to 0, 0, and then turns back up. Okay, and that's what f of x equals x squared looks like. What's the name of that shape? Parabola. What kind of function is this? Quadratic. Okay, now when we do linear functions, where is the y-intercept? Right, it's at the end. Still, it's at the end. The y-intercept is going to be there, and that's going to be helpful when we plot this. So it says plot the function x squared minus 3. That means the y-intercept is 0, -3. Okay, right? The y-intercept of the last one was 0, 0, right? We had f of x equals x squared because y-intercept was 0, 0. Now the y-intercept is 0, -3. So that can be helpful information right off the bat. But we're going to fill in the t-table just like we did last time. So -3 squared is 9. 9 minus 3 is 6. -2 squared is 4. 4 minus 3 is 1. -1 squared is 1. 1 minus 3 is -2. 0 squared minus 3 is -3. And then we're going to have some symmetry again, just like we did last time. So -3, +6 is up there. -2, 1. -1, -2. Right? And then we get these symmetrical points on the other side of the U. Oops, and I feel like I'm a little wobbly there, because that one goes like that. Okay, so now we're going to draw that. It's the exact same U shape you just drew, but notice it's just 3 spaces lower, right? Because now the y-intercept is 0, -3. That -3 lowered our U down 3 spaces. That's what it did. All right, that lowest point is called the vertex. And once you find the vertex, the lowest point, the parabola will always be symmetrical on either side of it. All right, so let's see this. Find the coordinates of the vertex and draw the axis of symmetry. Okay, that's like the mirror of our parabola, and we'll see that. So first, find the vertex. That's the lowest point. So that is the point 4, -3, right? That's our vertex. Now the axis of symmetry will be a vertical line that goes through that point. So let's draw that through there. I didn't really make that dark, but all right, you get the idea. And notice everywhere on this parabola, there are 2 points that are the exact same distance from each other, or from the axis of symmetry. No matter where you are, the one with the same y coordinate, right, is the same distance away from the axis of symmetry. So the first ones we did were very simple because the axis of symmetry was the y-axis, right? Right down the middle was the y-axis, and that made the actual numbers exactly the same, or opposites. But here, they're the same distance, okay? All right, now the U it will never be on its side, because it will never be on its side because that's not a function. These are quadratic functions, but the U can be upside down, all right? And so then the top is the vertex, the maximum point. All right, so find the coordinates of the vertex and draw the axis of symmetry. So the vertex is -3, 8, and then the axis of symmetry is the vertical line right down the center of the parabola through the vertex. All right, and this one's a little clearer than the last one. Like, see this point here. This point here is 0, 5, and over there is -6, 5. And right in the middle right, is -3, 5, right? Because they're both the same distance away from the axis of symmetry. Okay. So let's find two other symmetrical points on the graph. So I just found 0, 5 and -6, 5. You find some more symmetrical points. Well, it seems like there's one right here at 1, 3. And then over here is -7, 3, right? Both of those are 3 or 4 units away from the axis of symmetry. And you can see another, if you want to, there's more. Now, there's obviously ones with fractions involved, but there's another one, 2, 0. And the symmetrical point is over there at -8, 0. Right? And those, they're getting further and further away from the axis of symmetry. Forever they will do that. But they are the same distance from that axis of symmetry always, because they are symmetrical. Mirror image of each other. All right, so that's what we're learning today. So let's do some practice. Is that linear or quadratic? Hopefully you know that's linear, and if you graph it, it'll be a line. That is quadratic. And if you graph it, it'll be a what? It'll be a parabola. So this is a line, this is a parabola. Parabola is the shape, the function is quadratic. And quad means 4, but so why are these called quadratic functions? We talked about this earlier. I believe because a square, as in x squared, has 4 sides. What is the y-intercept of each of the functions, right? This is slope-intercept form, so its y-intercept is 0, 1. This is not slope-intercept form, but the y-intercept is still in that same location. 0, 7 is the y-intercept. All right, what point is located at the vertex? All right, it's right there, and that will be -2, -2. Draw the axis of symmetry, right? So you have to find the vertex and draw a vertical line through it. A line has arrows on the end. What is the y-intercept? The y-intercept is right there. It is 0, 3. What point on the parabola is symmetrical to the y-intercept? Well, right there, which is -4, 3. Right? Plot the function f of x equals -x squared and find the coordinates of the vertex. Now remember how this works, right? There's no parentheses around the base, so you do the x squared first. All right, that's why, when we're doing, when we want a negative base, we have to put parentheses around it. But this is not a negative base. It's the opposite of x squared is what this is. So let's see that. So you do -3 squared is 9, and so that's -9. -2 squared is 4, but then you have, right, -2 squared is 4, and the opposite of that is -4. And -1 squared is 1, right? Should I write this out? Yeah, the opposite of -1 squared, this is -1. 0 squared, 0, the opposite of 0, 0. And then we're going to get symmetrical points, as we always do. Okay, so we have -3, -9. -2, -4. -1, -1, 0, 0. Then we have the symmetrical points on the other side. Notice, we should know when we see that negative in front of, this is a, right? This is a in the form ax squared, right? And there's no bx plus c in this one. That when that a there is a negative number, you're going to have an upside down parabola. So it looks like that. Right? Good luck with the homework.